everybody. So today we are going over exponent rules and exploration. We went ahead and filled out this when we were still in school, so we're going to just do right below that. Use exponent rules to write each expression as a single power of 2. Find the value of the expression, record it in the table, and the first row is done for you. Okay, so remembering back to before, if we're dividing, that means we are subtracting. So I should have 2 to the power of 5 minus 2. 5 minus 2 is 3, so 2 to the third, or 2 times 2 times 2, which is 8. The next one, 2 to the fifth over 2 to the third, so that means I'm going to have 2 to the 5 minus 3, which is 2, so that means this whole thing is going to be 4. 2 to the 5 minus 4, which is 2 to the first power, which is just a regular 2. And then 2 to the 5 minus 5. So that tells me I'm going to have 2 to the 0. What do we think my answer is going to be? It's going to be 1. It is always a 1. 2 to the 5th over 2 to the 6th. What is 5 minus 6? Negative 1. So I'm going to go ahead and write that I have a negative 1. The way that you fix this is you flip it over to the other side. So it's going to become 1 over 2 to the first. It's always opposite. So if I have something on the top and it's a negative exponent, if I move it down to the bottom of the fraction bar, then it will be positive. 2 to the 5th over 2 to the 7th. So 5 minus 7 is negative 2. So that tells me I have 1 over 2 to the second, or 1 over 4. Okay, so using what you learned in Activity 2, answer the following 3 questions. What is the value of 5 to the 0? It is just 1. What is the value of 3 to the negative first? One more time. 1 over 3 to the positive first, or you can just write 1 over 3. What is the value of 7 to the negative third? That's 1 over 7 to the third. Or you could have written 1 over 343. Now, below, sort the expressions that are equal into groups. Some expressions may not have a match. Some expressions have several matches. Be prepared to explain your reasoning. I want you to take a couple of minutes, and I want you to tell me at least 3 that would go together. Okay, so some options that I see automatically. These two are going to be the same thing. I'm going to go ahead and say that this one and this one are the same thing. I'm going to say that this one and this one are the same thing. I'm going to say that this one and this one are the same thing. I'm also going to say that this one and this one are the same thing. Now there may be more, but these are just the ones I see right away. Okay, so now my next part, I'm looking at negative bases. Look at each expression, what is the same, what is different. So negative 2 to the 6th, you can do all of these on your calculator. Actually, I really want you to do them on a calculator or on Desmos to see what does it actually give you. So negative 2 to the 6th is 64. Negative 3 to the 4th is 81. Negative 4 to the 2nd is 16. Negative 2 to the 6th is negative 64. This one is negative 81, and this one is negative 16. So, looking at this, what do you think that the rules are? Like, what's the same, what's different? Well, it looks like these first ones have parentheses. So, if you have parentheses around a negative number, it does the exponent to the entire thing. If you just have a negative number to something, then that only does does the exponent to the number without the negative? So the parentheses basically just tell me, is it going to be positive every time? And if there are no parentheses, then it will be negative. The rules for negative bases. Okay, so if I have a negative number to an even power, it is positive. So thinking about this, positive, so negative times a negative gives you a positive. So if I have parentheses around the whole number and it's to an even power, then it will be positive. If it was to an odd number, then it would be negative. Okay, so the last part, a negative number with no parentheses to an even or an odd, gives you a negative answer. So if I have no parentheses around my negative number and it is to an even or an odd power, then it will always give you a negative answer. Okay, so find 3 different expressions to represent 27x to the 12th using your different exponents rules. So I'm going to give you one and then I want you to come up with the other 2. So thinking about this, I could have 3 to the 3rd power because that's what 27 is. And then x to the 6th over x to the negative 6. Because I would add those together, right? So 3 to the 3rd is 27, x to the 6th. I have to move this up to the top, so that would be 6 plus 6, so that would give me x to the 12th. Now, I want you to try the next 2. Okay, so I came up with just saying, okay, 27, I can just leave it the way that it was. X to the 11th times just a plain x. I would add those 2 together, so 11 plus 1 is 12, and then 3x to the 4th, I'm just adding or putting that 3 with everything. So I would have 3 to the 3rd, x to the 4 times 3 is 12. Okay, so why we need exponent rules. Exponent rules help us keep track of a base's repeated factors. Negative exponents help us keep track of repeated factors that are the reciprocal of the base. So reciprocal, remember, is you just flip it. We can define a number to the power of 0 to have a value of 1. So let's go ahead and just rewrite what all the rules would have been. So the very first one is the product rule. So let's say I had b to the m times b to the n. That would just give me b to the m plus n. The power rule, let's say I had b to the m to the nth. So that would just tell me I have b to the m times n. So remember, we've already learned these ones before. We did this not last week, but 2 weeks ago. The next one, quotient rule, b to the m over b to the n. So that would tell me that I'd have b to the m minus n. Negative exponents, so b to the negative n. That tells me that I'm going to have 1 over b to the positive n. This works every time, no matter what. 0 as an exponent, so b to the 0. Anything to the 0 power is just 1, so I'm just going to write a 1 there. And then power of a product. That tells me I'm going to have a, b to the m. All that this says is just go ahead and make everything go to that power. So a to the m times b to the m. This is where b can be any positive integer and n and m can be any integer. Okay guys, so how this is going to work is there's a whole bunch of these problems. At the bottom, I gave you all the real answers. They don't go along with it, so like the first one isn't going to be A, the second one isn't going to be B. You're figuring out where your answer should be, and then you're going to write the letter up at the top. So, looking at this very first problem, well, let's see. I can multiply these two numbers. So I have 2x to the fourth, y to the fourth, over 4 times 3 is 12. Now let's go ahead and add these together. So x to the first plus -2, so that would give me x to the negative first, y to the fourth plus -4, so that means that just goes away. I have a negative exponent. That tells me that it's going to go from the bottom to the top. So I'm going to have 2x to the, what's 4 plus 1? That is 5. Y to the fifth over 12. I can simplify this a little bit more. This 2 and this 12 are going to cancel. So this is going to become x to the fifth, y to the fifth over 6. So looking down at my answers, sorry, I don't know why I put y to the fifth. It should be y to the fourth. Okay. So y to the fourth, y to the fourth. Looking down at my answers, the answer is h. So I'm just going to draw an h here to remember, hey, I've already used that one. It's done. Okay, now for the second one. Very first part, we have our product of, what is it called? Power of a product. So this goes to the fourth, this goes to the fourth. So I have 2 to the fourth, x to the, what's 4 times 3? 12, over 2, x to the second, y to the negative first. So that tells me I'm going to have, well, these are going to cancel. So 4 minus 1, so 2 to the third. 12 minus 2, so that is x to the 10th. And then let's go ahead and bump this up so it's positive. So that becomes y to the first all over 1. So what is 2 to the fourth? It is, or 2 to the third, it is 8. X to the 10th, y to the first. So let's see. Y to the first, x to the 10th. Okay, so it is e. We are using e here. Okay, so what I want you to do now is go through each of these, and I want you to make sure that it shows up as one of these problems, okay? And then you are going to go and double check that you have the right thing. So online, you're going to tell me, so we have HE, and then you're going to tell me this one. So you're going to say, this is the first problem, this is the second problem, third, fourth, fifth, sixth, seventh, eighth. Okay, you're going to tell me each of those in order. Okay, guys, so we should have gotten H, E, B, C, F, A, D, G. If you have any questions on these, I will be having office hours from Wednesday and Friday from 9 to 10 a.m., okay? So feel free to send me an email. I will send you the link, and then you will have the ability to jump on and ask me some questions. Besides that, we're going to go on for another day, work on a Delta Math on this, and then the last day will just be making sure that we get our iReadies done. Have a good rest of your day and stay safe.